concept in Aurix Microcontrollers. Um, the agenda for today's presentation is high-level safety architecture. Here, as a part of safety concept in Aurix we will see what are the main elements which which constitute the detecting the faults in the system, and forwarding the notifying the presence of these faults to the user, and taking necessary actions before, and also achieving the safe state before any hazardous event takes place. Right, so we will see all these the main elements in high-level safety architecture. Then we'll move on to overview of safety related functions. Here what we have is as I stated earlier, Aurix is developed as a safety element out of context, and here some assumptions are made. Assumptions are made on the system design and requirements, so that based on some most commonly used commonly used use cases. Here here what we do, the assumptions which these assumptions are implemented within the microcontroller, and these are termed as safety related functions. We'll take an overview of these safety related functions in the MCU. Then we will move on to system level hardware requirements. Here when we say MCU is developed as safety element out of context, and we make assumptions on the system design and the requirements, right? Because it's not intended for any specific way application. So here we also make some assumptions which system integrator has to implement in order in a scenario where MCU is completely non-responsive, right? So we also list the system level hardware requirements which are required external to the Aurix to bring it into safe state. Now, next we will move on to discuss about Infineon, what Infineon offers for safety. So let's start with high-level safety architecture. Here we have internal safety mechanisms. These are the building blocks of the safety architecture in Aurix. Here, ISO 26262 defines hardware architectural metrics for each AC level. So in order to achieve an AC level, single point fault metric and latent point fault metric have to be required. LPFM and SPFMs have to be achieved, right? So when Aurix is designed, the all possible faults are identified, and they are classified as a single point fault, latent point fault, multi-point fault, and so on and so forth. So when we say faults are identified, and to mitigate the effect of these faults in the system, to detect these faults and control the failures in the system, in the MCU, in the Aurix, what we have done is we have developed internal safety mechanisms to detect all these faults and notify to the user. So now, how these faults, how these internal mechanisms convey the faults to the central unit of the safety architecture is that it is through alarms, and each safety mechanism. These alarms are generated by the safety mechanisms, and whenever when they detect these faults in the mission logic is performing safety critical function here. So when safety the related safety mechanism detects a fault in the mission logic, it passes this information through alarms. Please note that these alarms are predefined, and these each safety mechanism, it has got its predefined alarm, and it's very easy to trace back the source of the alarm and identify what fault had occurred and what was the cause of the failure. Coming to next element, which is safety management unit. This is a central part of our safety architecture. What safety management unit does is it actually it scans all the pending alarms. It scans all the pending alarms, and it triggers the reactions. Okay, so here you will see the internal reaction. So any fault in the MCU which is detected by the internal safety mechanism is passed to the SMU through alarms, and SMU user has to configure the reaction for these alarms based on the severity of the failure. So there are multiple options for generating the internal reaction for these alarms. User can generate the interrupt, and when interrupt is triggered inside the interrupt service routine, user can take the action and reach to safe state. User can also opt to generate the NMI, reset, complete reset of the system, and also just the CPU reset. So all these internal reactions are possible when on the occurrence of alarms. So coming to a safety management unit, what it does is it offers options to configure the reactions for the alarms, and also here there are two instances of in SMU. One is SMU core and one is SMU standby. In case of common it's avoided to avoid any common cause failure, preventing any reaction to takes place here. So what we have done is we have put two instances of SMU core and SMU standby. Here what happens is SMU core will be generating the internal reactions, and SMU standby, if it can be enabled or disabled, it will be monitoring SMU core whether this SMU core is generating the reaction or not. Okay, so it's basically SMU standby monitors SMU core whether SMU core is working fine or not. So if it doesn't, if the SMU core is not taking any reaction for the alarms, it can generate a safety mechanism within SMU core can trigger an alarm to SMU standby. So SMU standby is optional. It can be enabled or disabled. Here, these two instances handle also take the alarm. The voltage and temperature alarms are redundantly and diverse, handled by both SMU core and SMU standby in a diverse way. So this is all about failure, internal reporting of the failures here. And now coming to how the MCU failures are reported external to an external device which acts as a state controller. So here there is emergency stop. So when there in the presence of faults inside the MCU, each alarm can also be configured for emergency stop. So when alarm is reported, the emergency stop, what it does is without the intervention of CPU, it brings all the ports, all the critical ports to default state to cut off any communication from the ECU. Another external failure reporting option is a fault signaling protocol. Here, this is for each alarm you can enable FSP. Here, what two dedicated pins are available for a fault signaling protocol. They generate signal patterns for fault state, fault free state, and fault state. So when there is a fault in the MCU, and FSP is enabled for the corresponding alarm, then it will trigger, it will generate fault state on this error pin, and external safe state controller should monitor this and take the bring this MCU to the safe state. Now coming to the overview of safety related function, as I said earlier, Aurix is developed as a safety element out of context, and assumptions are made on the system design and requirements. Now with these assumptions, safety related functions are implemented within the MCU, and here will one of them is the safety computing. And here what we have is for SLD, for executing SLD applications, Aurix is equipped with Lockstep CPU, where we have redundant cores called checker core. Typically, a Lockstep CPU consists of a master core, a checker core, and a comparator. So what checker core is, checker core repeats what master core does, and comparator compares whether the output of these two cores is same. If there is a mismatch, then they generate this Lockstep CPU generates the alarm. So there is also a safety mechanism implemented in the hardware, which will always continuously monitoring the function of this Lockstep CPU. Or comparator, I would say. It will continuously injects the faults and sees whether this safety, whether the checker comparator is working fine or not. Coming to safe data and code storage options, here for code storage, the flash memories are protected with ECC codes, and here for flash, it's a single bit correction, and double bit detection options are there. And whenever there is an ECC error in the system, in the memory, these safety mechanisms detect them and also store them in the error tracking registers. There is also memory protection unit to avoid any unauthorized access to the memories and the code. And also address monitoring is done for the the monitoring is done for all these memories. Coming to safe intra-chip communication, all the bus transactions are protected with protected with ECC. So when there is a transaction has ECC error, then alarms will be generated. Safe infrastructure, we have clock monitors, supply monitors, internal watchdog timers, and temperature monitors. Each CPU has got its own watchdog timer, dedicated register set, and the alarms. There is also one single system watchdog, which can be controlled by the it's possible to configure which all safety cores can control the safety system watchdog. And here, coming to temperature monitors, there are two temperature sensors, and these are placed on different locations on the IC. So you can configure the thresholds for the temperature monitors, and when the thresholds are violated, the safety alarms will be generated. Coming to clock monitors, there are two peripheral PLLs, one system PLL, and there is also backup clock. There are clock monitors, and which will be monitoring the range of these clocks. Whenever the clock goes out of range, alarms will be generated. And also there are oscillator watchdogs, which will be monitoring the oscillator clock. For supply monitoring, we have primary and secondary voltage monitoring, which will be monitoring the supplies, and they will detect any under voltage event or over voltage events and generate the alarms. Now coming to coexistence of elements, lot of memory protections are memory protection and register bus level protection and register access protections are available in order to ensure freedom from interference in the system. Safe state support, as I already talked about, safety management unit. It does when it scans for the alarms, and it does generate internal reactions and external reactions to indicate presence of faults in the system. IO monitor, it actually checks for digital signals generated from the MCU, verifies. Okay. Coming to the safe DMA, we have this CRC calculation is done on the transfer data as well as source and destination addresses. So this is automatic CRC check. User doesn't have to do anything in their software. Now there is also enough partitioning done, and access protection is given in order to achieve freedom from interference in safe DMA. So coming to digital acquisition, actuation, and analog acquisition, here a lot of options are provided to implement, to facilitate customer to implement, these functions with redundancy and diversity. Hardware built-in test, there are several built-in tests to detect the latent faults, which is Pawar built-in self-test. This checks for the monitor supplies and power functions and supply levels. This is executed on cold power on reset, and only when this test passes, device will start. And there is logic built-in test. With this test, entire digital logic of the MCU is tested. And monitor built-in test, here also secondary monitors are tested, and also the error pin is tested with this mon based. Memory built-in test, all the SRAMs available in the system are tested with this M based for the ECC errors. Coming to system level hardware requirements, we have, as I said, we have made some assumptions while developing the Aurix, and we also some of the assumptions include that there are safety integrator needs to develop external to the voltage monitoring, external to the Aurix. So one of them is voltage monitoring, and as time window watchdog and fault signaling monitoring. So device has to, for a correct functioning device, has to operate in normal operating conditions. For that, any glitches in the power supply should be monitored by an external voltage monitor. So any user has to take care of any scenario where MCU becomes non-responsive. For this, user should implement window watchdog and fault signaling monitoring external to the Aurix. So here, the one iSafe state controller, which implements all these functions, the safe state controller should implement all these functions. That is voltage monitor, error monitor, and watchdogs. So one device that is Infineon offers is OptiReg PMIC, which has implemented all these functions. Coming to Infineon safety offering, here all the development is compliant with the safety ISO 26262 process, and hardware designed for safety. And it is as I have already explained all the safety mechanisms. Here the MCAL and safety library, all these are developed according as per ISO 26262 in Infineon. And also we provide for use implementing the safety application, we provide safety manuals, FMEDA reports, FMEDA documentation, safety case reports, and also safety analysis summary reports. Now we also provide premium support for helping customer to implement the safety application using Aurix. And also when it comes to MCAL software, it's a mix of it offers drivers with ASIL B and ASIL D level safety compliant drivers. That's all from my side, Dipanshu.
See my screen?
Yes.
Yeah, okay. Thank you. Thanks for the confirmation. Right, so let's discuss about the standard-driven development, for this particular achieving the safety and the security in the automotive sector. This is what we have been discussing from morning, safety and the security aspects, and adding those into the system so that the passengers or the drivers all are in safe. But if you look at the trend, what is happening throughout this particular automotive sector, if you look at there is a lot of digitization is taking place. It could be digitization in the supplier network, The digitization can be in the auto manufacturers or even the sales and the marketing, end market, after sales. One of the thing was which Kaushik was mentioning, that when the Tata is trying to give the advertisement, they are trying to focus more on safety. It's a kind of a new sales approach, which the digitization and the new stuffs are taking place. Or probably after sales, a lot of 3D printing parts or the predictive maintenance are taking place. In fact, even the systems are going to be built such a way that it gives us the indication automatically that okay, this particular part or this particular system is due for a maintenance, and let's go to the service station and maintain those stuff. So, but there is a lot of digitization is taking place in the automotive sector. As we earlier discussed, the vehicles were earlier pure mechanical vehicles, but now a lot of electronics, lot of software, lot of digitization is really taking place. But the challenge always remains is, are we building the safety inside the systems? Are we building the security inside the system? Of course, safety and the security is always, the two sides of the coin. It's still not the same, Sholay movie coin, where both sides were same. But the safety and the security, they are always the two sides of the coin, and they have to be there always in the vehicle or the automotive software, or it could be the automotive systems. So typically earlier, always there was approach was based on the quality, how quality or what is the quality of my particular system is, or my vehicle is, how maintainable it is, how reliable it is, how usable it is. But against from this quality based approach, the risk based approach started getting evolved over the time. These risk based approaches are for safety, risk based approaches for the security. Basically the assignment of or the assessment of the risks, what kind of risks may occur in the particular vehicle systems, or for that matter any system, be it ABS, be it a parking system, or it could be the ABS or anything. What kind of risk it can occur when a particular system is running. And then on top of the risk assessment, of course, the risk prioritization and the risk mitigation. So once we know what the risk is, then of course the risk mitigation comes into the picture. And there what basically the whole product development is based on such kind of a risk-based approach, where it clearly indicates that, okay, there is a risk for a safety, there is a risk for a security. Let's understand about that risk, prioritize that risk. Okay, what happens if this corresponding scenario appears? So when Sheshu was explaining, he clearly specified, one way of identifying the particular crash. Next thing is the preventing the crash. And then the next step would be the post-crash process. What needs to be done? Okay, I'm going to crash. The vehicle is going to crash. Now, what are all the different safety measures? What are the different analysis or the different mechanisms needs to be introduced within the systems? And there what majority of these standards got evolved over the years. Every process standards, every mechanisms, they started introducing such kind of an approach for the risk-based approach, where the risk assessment needs to be done, the risk prioritization needs to be done, and of course the risk mitigations, which again depends on the layers of protection for the security point of view, then defense in depth from the safety point of view or the security point of view, so that we ensure that the safety and the security are intact within the particular system. So when we look at the risk-based approach, of course, the risk-based approach gets across the different systems or the different subsystems within a vehicle. And again, there are different factors, like it could be the product specifications. I can just give an example of ETAS or infotainment or powertrain, BMS, everything. And what kind of a product design? So there will be always a human factor. There will be a product and project management system approach, how it needs to be done. What kind of a functional safety is really necessary in terms of all these systems? Cyber security, of course, nowadays the security is playing an important role, because majority of the systems are connected over network. They are supposed to be connected like There were recently I was checking an advertisement for MG Hector Astra. So they were trying to show that you can start your engine from a mobile phone, or you can stop your engine from the mobile phone. So of course, where then the security really plays an important role. So what happens if somebody really steals your phone, or if your phone is stolen, and then if someone tries to play around with your vehicle engines and all. So what kind of stuff it may happen? SOTIF, again, safety of indented functional safety plays really an important role in terms of risk-based approach. And the liability regulations and the certifications. Of course, there are regulations which have been getting introduced in the recent terms. Of course, the Sheshu highlighted about exactly the problem currently what we are facing with the regulations, but of course, over the time, in few years or in few months, we may have a regulation framework also ready for all kind of cyber security, or it could be related to the safety related issues. So when we look at all this risk-based approach, so there were the process standards, or there were the standards, they really start helping the development approaches to the system which we are building. So if you look at, there are multiple automotive standards. So it could be related to any of those stuff. So it could be related to the electrical safety. It could be related to the performance testing, like you can look at the different ISO standards. For electrical safety, again, there are different ISOs and IEC standards. And the coming back to then the software aspects of it, when you are trying to develop the softwares for multiple systems. And of course, we looked at the discussions in the past, the source code size are going to increase. So right now, currently, we are in terms of millions lines of the code for a vehicle, but soon we will have, the billions lines of the code in the vehicle subsystems or the vehicle systems. Then of course, the development approaches again starts driven through the processes. So again, MISRA and ATOSAR, again, they are one of the process standards, which basically helps in terms of improving your software quality and, try to reduce the faults which are going to occur within the software during the development phases itself. So of course, as we all aware, the functional safety standards, we had quite of discussions on this in past also, and today also, that ISO 26262 is purely talking about the safety related aspects of the particular automotive systems. But at the same time, when we look at from the cyber security point of view, again, there are a couple of standards like, ISO SA 21434 or UNEC WP 29 standard. It's a regulation standard, which is basically going to help in terms of improving the cyber security within the vehicle systems. So that's actually going to help in terms of, reducing the majority of the problems related to the safety and the security aspects within the vehicle systems. So then again, all the development, all the designs are going to follow as part of these processes. And then over the time, of course, these process standards are also going to evolve over the, like, for example, 26262, if you look at it, had a first version was in 2011. Then again, 2018, we got an update on the existing versions where, even the motorcycles and the semiconductors got introduced within that. So if you go back to say the 26262 part of it, of course, many of us have seen this in past and gone through with multiple approaches, like, it has 10 parts, 11 parts, 12 parts, different versions of the 26262. So which talks about, different levels. But the main thing happens always at, phase 4, 5, and 6, where the development starts happening at the hardware level, the development starts at the software level, and of course, the combination of hardware and software becomes at the system level. So majority of the problem starts appearing during the product development. And then of course, the fixes or the updates or the issues which needs to be really understand is at the product level. So if you start looking at, how does exactly the implementation process works, when we are saying, okay, I want to introduce both safety and security process in my product development. So here what is basically starts with the product concepts itself. When we look at the understanding of the product, and of course the designing of the particular product when it starts about in the concept phase. There what the functional safety 26262 talks about it from the safety point of view, whereas the SAE J3061 talks about the product concept based on the security aspects of it. But when we go for the say next risk-based approach, so here what again both the process standards, they talk more or less on the same stuff. But whereas now if you look at say from the safety point of view, it's the hazard risk and the risk assessment, which we typically call this as a HARA. Then of course we need to define the safety goals and the safety requirements, which will be a part of your product design. But if you look at this from the security point of view, now instead of we call this as a hazard analysis, it typically renames to something called as the threat analysis. So what kind of different threats may occur? You know, how secure is your system is? What kind of different threats may occur? How is the risk mitigations for those particular threats? That's what the security process is going to specify for. So you need to have again the security goals, you need to have the security requirements. So that means when the process is, or when the system is going to be built for both safety and security, of course, this risk assessment approach is being done for both at the safety level as well as at the security level. Then when it comes to the implementations perspective, you know, specification of electronics or electrical systems or the installations or the validations, everything. Now there what your different safety integrity level starts talking about. As we all are aware of, you know, ASIL A to ASIL D for the functional safety. Similarly, there is something at the security levels also where SL1 to SL4. So there can be a combinations of the you know, scenarios between safety and the security. The system can be very much safe, you know, that can be at the highest level of safety, but it can be a middle level of security. Or there can be a scenario, a system can be at the highest level of security, but you know, a lowest level of safety. But we cannot really avoid any of these part during the implementation of the particular software, or it could be the hardware, or I can say the wording as per the process standard is the product development. So main thing is at the safety, if I want to, you know, talk on the nutshell, is the defense against the random systematic failures. When we talk about safety, it's the defense against the random systematic failure. And whereas if I talk about, say, on the security aspects of it, it mainly defends against the negligent and the or you know, the willful actions against the threats which are going to be, or the cyber attacks, or the attacks which is going to happen on the system, and protect the device. So one thing is again both safety and security needs to be a part of always a system, because until they are there in the systems, the particular vehicle or the automotive system is not really, or I can say, you know, it's not really a trustworthy, because there can be a scenario where there can be a safety failure, because of which, you know, there can be a crash, or there can be a security threat because of which a crash may take place, or you know, someone hacks it and then you know, takes the control of your engine control, and then of course can happen anything. Of course, we all would have seen the Jeep videos, how this particular engine systems were been really hacked over the phone, and then you know, multiple stuffs are happening. Among these all, with respect to this cyber security and all, of course, there is a new standard started getting into the industry, is UNEC WP90, WP29. It's an automotive cyber security regulation. Of course, this has been a part of a United Nations Economic Commission for Europe, and it's one of the largest form for the international vehicle regulatory system. Of course, majority of the OEMs and the government bodies will start opting of this. And again, this is mainly related to the cyber security regulations of it. So one of the important thing is, as per this particular regulation is, you know, the vehicle must be able to detect and prevent the cyber attacks. So what we saw earlier was based on the risk-based approaches, where, you know, risk assessment and then the corresponding handling of the risk and the risk mitigation. So basically trying to detect the attacks, and also how we can prevent it. So basically do the mitigations across it. It also supports the monitoring of the vehicle manufacturers with again related to detecting the threats, vulnerability, and again the cyber attacks. So it's mainly related to the detecting those threats and vulnerabilities, what could occur within a system when a particular cyber attack takes place. And also providing a data or the capability to enable an analysis in terms of attempted cyber attacks or previous attacks. A kind of a data base needs to be provided so that next time when a new development happens, at least these databases threats or the cyber attacks which happened in past can be incorporated so that these things won't repeat again. But among all of these regulations, the important part is always to understand about the cyber security process is 21434. And again, when we talk about these all safety and security, it involves the softwares, it involves the hardwares, and of course gets the product development. So what typically we see the more challenges when we say when we are designing a particular safe and the secure systems, it always starts from the requirements. It could be the safety requirements, or it could be the security requirements. And of course, the requirement traceability plays an important role with respect to this, because all the requirements have been taken in part of a design, part of an implementation, and of course as a part of a testing, so that you ensure that you did not miss any of those safety requirements or the security requirements throughout the product development. Again, when it comes to the coding standards enforcement, like whenever there is software development, we looked at the different approaches like the MISRA coding standards or the AUTOSAR based approaches. We need to ensure that those coding standard compliances are again has been fulfilled to reduce or to remove the vulnerabilities within the software which is being developed. Again, the functional safety standards or the cyber security standards talks about the data flow control flows or the code coverage analysis, just to ensure that the complete software is been really tested. Each and every line, each and every branch of the software is been really tested to ensure that what exactly the particular system is going to behave when a part of the software or a part of the code is really going to execute in that. Then of course all those tests are running on actually ECU based microcontrollers or the ECUs or the microcontrollers to ensure that you get the same results. The tool qualification, of course, all these process standards ensures about the qualifications of the tools, because majority of the times the OEMs or the vendors who are developing these systems, they try to use the automated tools, because of course the softwares are so huge, the systems are having so many features, so the tools plays a really important role in terms of automating the whole process. So how qualified the tools are, how you can trust the output of the tool. So there, what again the tool qualification plays an important role in terms of all of this, designing the safe and secure system. So by following majority of all these process standards and the safe systems or the approaches as per the process standards, of course, the particular software or the system, we can always highlight that, okay, it conforms to the safety and the security. And as being the organization, LDRA, we supply the different tools on the solutions, particularly in terms of verifying the softwares, which really helps in terms of getting the compliances with respect to the different process standards. It could be the ISO 26262 or 21434 related to the cyber security, and provide the automated tools in terms of achieving these all safety systems. So yeah,
we are already
yes, almost I'm done. I'm just providing the concluding remarks. So in nutshell, if I say the safety and security always are the two sides of the coin, and they are based on the different process standards. So thank you.
Thank you so much, Shrikant. We will now have Mr. Khushwant Pawar, Head Cybersecurity Solutions, Mobility Regional Market India from ETAS Automotive on the topic preparing for safe and secure mobility.
Okay, thank you, Dipanshu. And let me know if you see my screen. I will share my screen. So is the screen visible now?
Yes, yes, your screen is visible.
Okay, excellent. Okay, so thank you, Mobility Outlook, for this opportunity. I'm here to present or share my few cents on preparing for a safe and a secure mobility. So, brief overview of my agenda is that I will cover safety and security for next generation. What's the expectation? Some topics on hardware security module, because that's at the centerpiece of safety, of course, security too. Some parts of what a script can do, and then we can have question and answers if there is any time. To start with safety and security for next generation, safety and security we see as complementary streams. There is, of course, some fundamental differences and approaches towards safety and security. They need to be aligned, of course, in some or the other way, and we will highlight some potential conflicts also. So the first part is we always have been saying, and we've heard it since morning, there is no safety without security, and the complementary is also true. The view is that functional safety is an inside-out view of a system, whereas cybersecurity sort of is an outside-in view of the system. But in general, we see that safety and security are complementing each other. Both are at the core of electronic automotive software development and reliable performance over the lifetime. Now, a quick look at some fundamental difference, why we say that these are not the same. Safety focuses on risks that may result from random malfunctioning that could lead to, some sort of harm. So system-driven harm to any individual or any other systems. That's a view, and that's why it is like inside out. Whereas security is more driven by risks resulting from motivated attackers who can manipulate, who can take control of the system and then further exploit the vulnerabilities in order to harm the system intentionally. So the unintended and intentional is the big difference that we are trying to address when we talk about safety and security. Of course, there are standards for both now. ISO 26262 has been in acceptance for quite some time. In practice, also a lot of earlier speakers spoke about ISO 26262, and that's more driven from functional safety. And automotive cybersecurity standard is 21434, which is almost ratified now. So it is also getting acceptance, but it will evolve even further. One thing that is clear is both these processes have their own specific differences, and they need to be aligned with the product development processes or product engineering processes in the overall development cycle. And just as an example, while I say that the development NPI, NPD, whatever might be being practiced for a new product launch or a facelift in automotive development, safety and security should ideally start at the right points, like right from the item definition, so to say. And safety would take its course. It will take hazard and risk analysis, then safety goals will be defined, some measures will come into picture. Parallelly, security will take its own route. Threat and risk analysis, security goals and measures will be created. A security concept and a safety concept will be further then integrated into the design. And then once the implementation phase is over, during verification and validation, security will branch out again for penetration tests or integration tests and alike, whereas safety would go for test safety mechanisms. Ultimately, to come up with a certification, if we look at the WP29 context, where type approvals are needed, and could be something like a final cybersecurity case, so to say. And the safety branch will consider the safety assessment, come up with a final report that yes, this is from functional safety perspective, a ASIL-D compliant vehicle or a CE compliant vehicle to determine its SIL levels. This is where safety and security case rests, and only difference after this part would be the post-production topics, which are more relevant for cybersecurity, little less relevant for safety. Of course, safety implementation are expected to function as is in the field too, as expected. But from the standard perspective, there is not much which talks about post-production topics, whereas cybersecurity has an elaborate explanation on what are the steps from managing and mitigating field or life cycle security related issues, how to do incident response, and so on and so forth. A small view of what we say a conflict between the safety and security has come to view in past several years of implementation, working with several OEMs and tier 1s is, since the objective are different, intention versus unintentional failures, the mechanisms to really address these two safety and security elements are also different. So a good conflict example would be safety protection implemented, like fault tolerance implemented in an ECU functionality, which could be triggered by an attacker, so that the vehicle moves into a safe mode of operation, or the ECU goes into a safe mode of operation, impacting other functionalities that may not function the way they should. So this actually renders a compromise in the availability aspect from functional integrity. So that's a clear breach that has led to a violation of functional safety. However, if you are looking at protecting these kind of functionalities from an attacker, you would want to implement, let's say, any authentication or encryption sort of functionalities. Now, these functionalities will eat up a lot of computational time. They will add latency into the device. So the purpose of having a safe mode triggered in an actual fault tolerance mechanism use case might get delayed because of the crypto computations that may lead to actual functional safety conflict. Right, so these are one or two small examples which are practical, implementable and unresolvable dilemmas that as a software engineer one might face. There is no consensus in the industry on how to address this, but fundamental expectation is clear. Cybersecurity must prevent attackers from being able to manipulate the functional safety of the vehicle. That's one. And on the contrary, functional safety must ensure that cybersecurity mechanisms or security faults should not have a safety critical impact. And that's an important element. So when we look at all of this is now why I took the example of the conflict, because this conflict is driven by the need for computational power for crypto functionalities versus the host application, which is actually trying to drive safety relevant components or functional safety components. So hardware security module, the HSM technology, is actually at the core of this topic, and that's why I took that example. So Sheshu earlier in the talk mentioned that there is defense in depth that is needed. Now, defense in depth actually is starting from the cloud to device communications, then internal E&D architecture communication security, then functional partitioning is one way to look at it. And the last and the most important element is the device security. And device security is includes several use cases like secure updates or secure onboard communications, trusted boots, authenticated boot, or even storage of secure storage of crypto credentials. All of this is important, and this is over the last few years is driven by the hardware security module technology, which offers a separate core for all of this functionality. All the crypto runtime, all the crypto primitive storage is done in this core, and this is independent of the host core. So that's one problem is solved. We have all the crypto and important elements secured in a separate core and not easily manipulatable. So that problem is resolved. Second is the crypto, the HSM core runs a HSM firmware which can work closely with AutoSAR, non-AutoSAR stacks. Could be easily integrated and works via APIs. Right. This is the kind of implementation that is more and more popular through the HSM technology. The most important part is that it has its own HSM processor. There is a processor underneath the core. It can run cryptographic functions. Plus, it has its own operating system and stack. So as even in multi-core context, resources can be used in an optimized manner. But it has its own challenges in implementation, because actually direct conflict with safety to a great extent, because most of the HSMs that we are aware of until last couple of years are not designed with functional safety in consideration. A lot of times ISO 26262 based compliant quality management is not followed. A good example is Lalita in her presentation actually mentioned, and there was a poll question I saw that the hardware of the MCUs are ISO 26262 compliant since the development itself. So when we look at the HSM itself, there is no safety goal directly associated. Second part is generic approaches of HSM firmware having some functional safety implemented will not help. Instead, a safety relevant case-specific implementation of functional safety in HSMs would be needed. Now, what does that mean? For any application that is using an HSM, let's say the ECU is, let's say, ASIL D, it might need a use case specific safety compliant HSM also. Now, this makes it all the more complicated because HSMs will be functioning in ECUs which are integrated in several ECU environments. So some ECUs would be ASIL D, some ECUs might be ASIL C, or ASIL A for that matter. What it leads to is no freedom from interference. So what does ISO 26262 say is, freedom from interference is defined as the absence of cascading failures between two or more elements that could lead to violation of safety requirements. So in a sense, an ASIL B element, which is a subset of a bigger system, should not drive the higher ASIL component. In this case, as you can see, there is a ASIL B device steering control trying to drive the gateway ECU, which is ASIL D. So here cascading is possible. Here a failure from this ECU can lead to failure in the other ECU. This should be avoided, and this is where a lot of mechanisms would be needed going forward, like design dependence analysis, for example. So the solution for this problem is qualified HSM firmwares that are actually designed as a safety element out of context. And so when we look at hardware being designed as a safety element out of context, even the HSM firmware should be designed as a safety element out of context, should be easily integratable with by preventing interference between the HSM and the host cores. And most importantly, there should be no need of actual partitioning of memory and memory protection, because it is working on a completely separate core. Cycle HSM from Script is one such solution that has all of these three attributes and has been running in more than 100 series projects till date. A quick case I would want to take is, let's say you want to implement onboard communication security. Now, how would you go about it with respect to HSM and safety and security? One is the typical threat and risk analysis is a given, right? You go with the security analysis, design some countermeasures, take the security risk and design the countermeasures to, just a minute. Okay, to determine the desired safety integrity levels. Now, once this is done, there are also several other mechanisms in trying to balance how you are going to implement this. So AutoSAR has specified some mechanisms to detect and handle faults on a communication network to ensure that no uncorrupt messages are actually flowing around in the bus. One such mechanism is the SafeMac, where safety critical messages are use say cipher-based message authentication code, and this Macs usually are used by the HSMs to do the calculation, do the computing, and then determine whether the messages are corrupt or not corrupt. This function is ensured. Yeah. So, however, this requires a lot of high performance in the HSM firmware, and obviously it is in conflict with the cost targets of any device for that matter. How can a script help? So a script offers services across the life cycle of security from security consultation perspective. Script has a huge portfolio of products, right from the Cycler HSM, as I mentioned earlier, to Cycler IDS, which is, as Seshu mentioned, intrusion detection system needed for the future vehicles. We have AutoSAR stack that can be offered for safety compliant developments, right from the BSW to the flash bootloaders and OEM specific components. And last but not the least, a script along with ETAS provides a complete safety consultation package to support software and safe software and system development. Where to start? First is introspect, try to figure out where is your organization with respect to safety and security development, talk to experts. Script has been providing this consultation to OEMs and tier ones for more than a decade now. Define your organization's role, and your role specifically could be safety concept creation or security design development, or maybe aligning processes between safety and security, ISO 21434 or 26262. And then acknowledge that aligning the competencies for safety and security is very, very crucial to really release safe and secure vehicles. So thank you very much once again to Outlook Mobility, and thank you everyone for listening to me. Questions, if any?
Thank you so much, Mr. Khushwant. We will take the questions in the end of the session if there are any, but in the interest of time. Before I introduce the next presenter, I would like to remind our audience that we have a very interesting panel discussion coming up after this session. The panel discussion would be on safety-driven automotive security, decoding the industry approach. So I would like to introduce to the next presenter, Mr. Animesh Kumar, Head of Customers India and SEA, HSM Technologies, who will talk about how advancement in location technology and data are rapidly shaping the future of mobility in India. Over to you, Mr. Animesh.
Hey, thanks, Dipanshu, and thanks to fellow panelists. Let me just pull up my presentation slides. Give me a second. Just let me know if you can see my screen.
Yes, we can see your screen.
Great. Okay, with the hide the thumbnail. There you go. Okay, so thank you, and just give me a second. Let me start the clock so that I know I don't overrun. Perfect. Okay. Thank you, everybody, and welcome to this session. In short, we'll be talking about how the HERE looks at location technology and how HERE is shaping the future of mobility in India. In short, when we talk about what do, we actually provide what we call as a digital representation of reality, which is living, dynamic, and continuously updating. Just a short introduction. We are the world's #1 location and data technology platform company. Some credentials for India. We've been there in India since 12 plus years. First came in 2009, and we've been operating here since then. More than 50% of the employee of here, which is a global company headquartered out of Netherlands, is based out of India, which is roughly about 4,000 plus people. And these 4,000 plus people are spread across, both the global capability center, where we have got the data engineering and operations, R&D centers, digital operation services, and definitely our go-to-market operations, where we go and address the customer and solve the customer problems. Deep diving into, I would say, what's happening in the automotive industry. Now, there are a lot of forces which I would say, is forcing the automotive industry to transform. We've heard about digital transformation, and the automotive industry is, I would say, no different, right? So we talk about there are 8 different forces that is in play from a here perspective that we see in the automotive. Sorry, okay. Okay, I thought I heard somebody speaking. Okay, the first one, which is the connectivity and convergence. Now, connectivity and convergence is I would say, a very, very important factor, which turns the automotive or the car into a digital platform. The second, which is the heterogeneous society. Now, when you talk about heterogeneous society, this is again one of the transformative forces which is pushing the automotive industry. There is the female empowerment. There is the Gen Y or Gen Z, as you call it, and then there is a need from the rising middle class, which talks about personalization and customization. So automotive industry is no different compared to any other industry where people are talking about these kinds of requirements. Third aspect is the urbanization. Now, we all are very, very, we are seeing it happen in our own country, where there are mega cities, and Delhi has grown so big, Bombay has grown so big, Calcutta has grown so big. And then we are seeing the city infrastructure, right? Both in terms of the road infrastructure, as well as even the data connectivity. It has grown leaps and bounds, number of roads, the quality of roads, the subways and the bridges, etc. Apart from that, what is also happening is that there's a huge amount of, the mega corridors being formed from one city to the other cities. Now, all these trends combined together gives roots to rethink the traditional business model from an automotive perspective, and they have to now look at and embrace new opportunity. Personalization and customization of the customer experience throughout the buying process becomes a very important factor. The platform economy, moving from a sequential value chain to an on-demand economy, becomes another very, very a critical aspect. Value for money in sharing the economy, needs to innovate, replicate efficiently successful strategies from a different region, say in Europe or US, and bring it out in India. And as the other panelists talked about safety and security, innovating to zero. Now, innovating to zero is also very important, because today we are dictated by the requirements of the consumer, we are dictated by the regulators, we are dictated by the safety agencies to aim for a zero emissions, to aim for a zero congestions, zero accidents, zero security breaches. Now, today our automobile has become a software world, right? So it's very important. And you heard about it, so I don't want to dwell into it. It's becoming a software factory. So it's important for people to have ensured that there is a zero security breach as far as these equipments are concerned. We've also seen a shift from, bricks to click. I mean, there was I would say, brick and mortar company. Now we are talking about a new norm of the future retail with online e-commerce as a standard. That is becoming. We are seeing so many advertisements in our daily newspapers and televisions and radios. You know, when we talk about how a car was gift wrapped and delivered to you at your home, and all was done online, and the entire digital journey of a customer was managed online. So these are something which is very, very new, and it is something, maybe you can call it an effect of COVID or whatever you call it, but these are fact and a reality which is impacting the automobile industry. Then comes the cognitive area, which is, you know, enabling an autonomous world for everyone. I mean, there was a time when the autonomous was not that relevant, and it was never used, I would say, in the automobile industry. But today it is becoming important. We have seen advertisement in the TV where BMW parks by itself and all that, right? So these are the areas of cognitive which is becoming a reality in this industry too. Health and wellness and well-being. See, today, when you sit in a car, right, it's a fiefdom, it's your home. So it is important for having air quality monitoring. It's important to have a seat comfort, mood lighting, you know, your anxiety level monitoring, driver fatigue alert. These are all going to become a big standard, and these are all, I would say, the transportive forces which is pushing and forcing the automotive industry to adopt and change. When we talk about the challenges, you know, what are the challenges that the OEMs has? We can look at it into 4 different quadrants. You know, next 5 to 10 years will determine the fate of the OEMs and where they play. This reflects, and this X and Y chart that I've displayed reflects the pressure on the OEMs and the ability to achieve margin. There's something called fallen OEM. These fallen OEMs are the people who have few tech capabilities, and they're potentially out of the market or they have been acquired. Then there is something called stagnant OEM. A stagnant OEM could be a strong brand at one point of time, but there's no growth for them. They're not growing, right? They're a big auto company, but they're not growing because the capabilities of the car is not there. Then the third aspect, which you see on your left-hand side, which is the OEM as a hardware provider. Let me give you an example of Foxconn, and I'm sure a lot of people must have read this in the newspaper, right? They're talking about developing EV, and they're talking about taking the EV out of the market, also providing this platform as an OEM to be rebadged to the other OEMs. So we're talking about a very, very a different world that is changing the automotive space. So the question for the traditional OEMs would be, you know, fallen giant, do you consolidate or do you exit, right? Stagnation, how do you add growth? Hardware platform, do you become a metal blender, or do you strive to go towards data and mobility manager, which is a direct consumer reach? And I'll tell you, frankly, if you see the kind of advertisement that is going on in the market today, while they talk about the kind of an engine, what I call in the data world is speeds and feeds, but they're also talking about the features and functionalities that a vehicle has today. So there is a very, very, I would say, you know, shift that is happening in the automobile industry, and it is all for us to see. This particular slide basically denotes, you know, what we call as a consumer journey. A consumer journey when he starts from his home and till he reaches to his parking garage. Now, for example, there are many consumer personas, and each of them would require a customized, a personalized, and a consistent experience throughout the journey. So it starts with his at home, where the journey begins, where he's planning for a seamless mobility, right? When to leave, what mobility options to consider, what time do you arrive at your destination, how comfortably do you reach your destination, what are the various mode of communication that you take. And while you're there, while you start on the journey and you're on the highway, right, there are something like you know, advanced driver assist assistant system, the ADAS features. Then there are precise positioning, giving time to enjoy for that persona. The infotainment system, right? There's a huge infotainment system that is built in your car. So how do you enjoy it? And these things is possible only if you have features like precise positioning and ADAS features. In-car vehicle infotainment system. How do you enjoy it, right? Then there's something called HNOD. HNOD is something which is air navigation on demand, and this is very critical because today, when you talk about giving an experience to your consumer right from his home to his end destination, it is important for him. It is important for you to give him a freshest of experience. I mean, it's a fresh experience. That means the data that you provide to him has to be fresh, has to be current, has to be very, very recent, right? Because in location world, it's a very, very dynamic world, as I told you, that it's a very living and dynamic and continuously updating world. So freshness of the data that you provide becomes very, very critical. Apart from that, definitely connecting with the infrastructure. There are I would say standards like V2X, which is vehicle to everything connectivity, with which you connect to the outside world, so that while you're sitting in your car, you can communicate your car. Your vehicle can communicate to the outside world, and which would lead to both connectivity, giving you an experience, and also will collaborate with the external world for your own safety. Apart from that, definitely reaching your parking space, ensuring that the parking space is available, ensuring that if you're working on an electric vehicle, there's an EV charging available, so you have a hassle-free parking, hassle-free EV charging experience, and anything else that you may desire. So this is what defines a total journey of a persona right from his home to his end destination. What is also important to understand today is today in any mature market, right? The ability to sell more car is dependent on conquering more market share. How do you market share? Either you expand the market or you go and gain market from your competition. Now, here it is important for you to shift your mindset. Like, for example, in automobile industry, the planning happens typically before SOP, which is your SOP would mean your basically start of production. And it ends with this SOP, and there is a monetization focus, which starts with point of sale, right? POS. But with the connectivity opportunity, it is important for the automobile to provide a scalable platform, a platform that has a headroom for updates and upgrades, very similar to your mobile and your computers that you have today. There has to be headroom for updates and upgrades. So updates and upgrades for your hardware, for your software, for your connectivity. So there is a shift that is happening. And another very, very important aspect is owning the user experience while the user is sitting inside the vehicle, right? You have to maintain control over the vehicle and user data, over the monetization channels which are there, like marketplace or in-vehicle infotainment. And the connected car captures all these revenue pools, which wasn't available at one point of time. So OEM needs to be in charge of this consumer's in-vehicle digital experience, or digital life, as we call it. And with IVI, it represents almost, I would say, almost 30% of the system time the consumer uses the in-vehicle infotainment system. So it is very important for you to manage the digital experience and create a digital brand for yourself. There's definitely a brand, the car that you sell, the company that you are, but there's also something that I'm talking about, which is a digital brand. Key challenges and how to address them. Okay, so here basically what we're talking about is over the next 10 years, cars are going to become more and more autonomous, but drivers will still be part of the loop. While it becomes autonomous, you have the Tesla going on its own, you sit on the side, do nothing. But to provide a truly end-to-end experience inside the vehicle to drivers, it is important for the car to drive itself. And when the driver takes over, it becomes crucial that it's a very seamless, and the vehicle has got the intelligence to know what to do and when to do. The importance of precise location for automotive is constantly growing. And one of the most important thing is vehicle need is for navigation and doing it safely, moving from point A to point B with a very precise position on the road. And I'll tell you why this precise position becomes very important, because that's where the future of autonomous comes into picture. And as you do that, right, you require standard definition maps for guidance and route planning. but also high definition data for precise positioning and autonomous path planning. Because of course, I mean, standard definition map may not be very everywhere. So on certain, and at the same time, it is also important to, it is also very important for you to be very clear that on certain roads, that autonomous vehicle is allowed to operate, while on the other roads you require a driver assistance. Now, this definition between automated driving zones and the rest of the roads needs to be done in advance in order to avoid the driver to avoid a dangerous situation of overestimating or misreading the intention of the system. And last but not the least, what is important is have to have a fresh data across all these use cases that we have spoken about. In the last, I just want to take you through a small video. This is the very reality in Europe. This is just 2 minutes. I know I've gone over by 1 minute. This talks. Sorry, there's no audio, but this talks about we had a this is in Europe for a company called Ford, and you can see how the hazard system is helping it to safely navigate on the road. And these local hazard operations, you can generate multiple leads. These are all connected systems. They're connected onto the cloud. And the advantage of this is that while the car which is on the road, which is already managing these hazards, taking care of it, it can also help send the data to other connected vehicles on that road and help them navigate it safely. So thank you. That was